Assalamualaikum and good evening everyone. So today we are going to revise about the combustion process. I know that every one of you are so familiar with this process as we already learned this in refinery. So combustion process is a process that used to convert the heavy hydrocarbon molecules into lighter hydrocarbon molecule through various processes. So these heavy hydrocarbon molecules are from the separation process, as we know that separation process of the crude oil is mainly based on their boiling point. So the combustion process involves cracking and rearranging of the molecule of crude oil to add value of the product. So in major refining process, there are three steps, which are the separation, combustion and treating. So I want to focus on the combustion and I want to highlight on the cracking process, as the other process will be covered by my friend. Okay, so for the cracking process is a process that used to upgrade heavy hydrocarbon and high boiling fraction crude oil to lighter hydrocarbon and low boiling fraction of crude oil. And this cracking process will produce a valuable products. So for cookers is a process that used to convert heavy residual oil into lighter product and distillates. And the next is alkylation process. Alkylation process is somehow contra to the cracking process. Alkylation process is a process where the isobutane react with butylene and produce alkylate. As we know that alkylate is a high octane number of gasoline produced. And the fourth process is the reforming process. Reforming process is a process that converts naphtha into higher octane molecule to produce reformate. As we know that, we also know that reformate is a high octane number of the gasoline component. And the last process is the isomerization process. Isomerization process is a process where convert the linear alkene molecule into high octane branch molecule, and it is used to obtain high octane number of crude oil. So for isomerization process also used to convert the butane into isobutane, and isobutane is used in the alkylation process. So I'm going to proceed with the cracking process. So first is the catalytic cracking. Catalytic cracking is a process that uses catalyst to crack the carbon-carbon bond, and the reaction is carried out in a furnace since the heat is required. So it is a fast cracking reaction due to the catalyst added. So excess cracking will lead to the coke formation, and it is undesirable reaction. So the purpose of the catalytic cracking, as I mentioned earlier, it is used to produce gasoline with high octane number, and it is used for the decomposition of heavy hydrocarbon feedstock to lighter hydrocarbon. So there are two types of catalytic cracking, which are the fixed bed catalytic cracking and fluidized catalytic cracking. But for today, I'm going to explain about the fluidized catalytic cracking only. So the feedstock of the catalytic cracking, as you can see here, the feedstock is the heavy atmosphere gas oil and vacuum gas oil, and the catalyst used for this reaction is usually acid treated with silica alumina and zeolite. The main reason why these two catalysts is used because it have the desirable properties such as stable to high temperature. As we know that the reaction is carried in a furnace, and so catalyst with high temperature resistance is needed. So the next desirable properties is high activity or selectivity, which the high activity will lead to conversion of the higher hydrocarbon into the lower hydrocarbon molecule. And the third desirable properties is the large pore size. As we know that the pore size is somehow related to the active site for the catalyst binding, and it will speed up the reaction. And the last one is catalyst with low coke production is favorable at high cracking activity. So as you can see here, the product produced from the catalytic cracking is the naphtha, gas oil, distillate, and wet gas. So these are the diagram of the fluidized catalytic cracking and catalyst regenerator. So it have two functions, which are to catalytic cracking and the catalyst regenerator function. So the advantages of this process is it enables the fluidization of catalyst particle in the feed stream, and it will regenerate the catalyst by burning off the coke. So the process started from here. As you can see, the feed will mix with the catalyst at the bottom of the riser. This is the riser, okay? And the mixture of the catalyst and the feed will move up to the reactor through the riser. Okay, so here at the reactor is where the cracking process occurs, and it is an endothermic process. So the product produced from the catalytic cracking will go out from the upper part of the reactor. So meanwhile, the coke and the catalyst will go to the regenerator for the catalyst regeneration process. So here at the regenerator, coke burn off and catalyst regeneration take place, and the catalyst produced will be reused back for another cracking process. And here at the regenerator, the process is exothermic process where the heat will be released, and the flue gas, which are the carbon dioxide gas, will go out at the upper part of the regenerator. So the cycle is repeated. So we are going to proceed with the next cracking process, which is the hydrocracking. So hydrocracking is an efficient low temperature catalytic method that used to convert the refractory middle boiling or residual material to distillate range product. So distillate range product can be like kerosene, jet fuel, naphtha. Okay, so it is a combination of cracking, hydrogenation, and isomerization. And the difference between hydrocracking and catalytic cracking is hydrocracking is considered as a treating process due to the hydrogen will mix with the catalyst and remove contaminant in the crude oil. So the example of the contaminant in the crude oil is the sulfur, oxygen, nitrogen, and heavy metals. So the purpose of the hydrocracking is more or less same like the catalytic cracking, which is it used to break the carbon-carbon bond or large aromatic compound, and it used to remove the contaminant. It involved the drastic reduction of the molecular weight, and it also used to produce a high octane number of gasoline and product with a low sulfur content. As we know that it used to remove contaminant, right? Okay, so next the feed, the catalyst, and the products of the hydrocracking. As you can see from here, the feedstock of the hydrocracking is the heavy gas oil from the atmospheric distillation column, and the vacuum gas oil from the atmospheric distillation column, and it also and the feedstock is also from the coker gas oil from here, you can see, and the cycle oil from the catalytic cracking. So that are the feedstock of the hydrocracking, and the catalyst that usually used for this process is the silica alumina faced with rare earth materials such as palladium, platinum, and nickel. And zeolite is also used in as a catalyst, but with the nickel molybdenum or nickel tungsten. So the product produced from the hydrocracking is the gasoline, naphtha, and middle distillate. Okay, so let's proceed with the hydrocracking process flow. Okay, the process is started from here where the feed and the hydrogen mix together at the pre-treat reactor, and then the mixture will be discharged at the hydrocracking reactor. Here at the hydrocracking reactor is where the cracking process takes place, and this is where the feedstock is cracked into gasoline range material. So the mixture of the cracked product will be discharged at the separator, and here at the separator is used to separate the hydrogen gas and the product. So the hydrogen gas will be discharged at the top of the separator, and it will be used again for another cracking process. Meanwhile, the product will go to the fractionator. So here at the fractionator, the product is separated according to its boiling point, and the product produced at the fractionator is the middle distillate, heavy naphtha, lubes, and olefin. The product will be discharged at the top of the fractionator. So that's all from me for the cracking process for the hydrocracking and catalytic cracking. So I have two questions for you. So the questions are: give 3 examples of the conversion process, and that was the first question. And the second question is the state 1 desirable properties of the catalyst used in the catalytic cracking. So that's all from me. Thank you.